Pleasure for me to introduce today's our speaker of fifth session, Mr. Praveen Rathod, who is going to teach us about the HEC-HMS and HEC-RS software. Presently, Mr. Praveen Rathod is the research scholar at Sardar Vallabhbhai National Institute of Technology, Surat. He did his graduation from Visvesvaraya Technology University, Belgaum. He secured gold medal for his outstanding performance in the graduation program. He did his master in water resource engineering from SVNIT Surat. Currently, he is pursuing his PhD on research topic turbulence and vortex characterization at flow pair interface in score modeling. He is the life member of Indian Society for Hydraulics and his research interest is in hydrologic modeling, GIS and remote sensing, hydraulic modeling and computational fluid mechanics or dynamics. He has three science journal papers and 12 national and international conference papers. In addition, he has one book chapter in the development of water resource in India. With this, once again, I welcome all of you for this session and I would request Mr. Praveen Rathod to start the session. Mr. Praveen Rathod,
Yes, sir.
you can proceed.
Yes, sir. Thank you. Thank you for the nice introduction, sir. And good morning to all. So I'll begin with the basic introduction to the rainfall of modeling, and then we'll move on to how exactly modeling can be done using HEC-HMS. Okay, so I hope I'm audible to everyone. Can anybody confirm, please?
Yes, you're audible. Sir, it is requested to please, can you turn on your video?
Okay. So I'm sharing the screen now.
Yeah.
Okay, so I hope my screen is also visible to everyone.
Yes.
Okay, thank you, Alpesh sir. Yeah, so rainfall modeling, when we do, we must know what kind of modeling we are interested in. Like in rainfall modeling, suppose we are thinking of going for deterministic model or the stochastic model. I hope in previous lectures you might have understood what is deterministic and stochastic models. In brief, deterministic models are those whenever you give in any inputs, they will have the specific or certain output that won't change. But when you consider the stochastic models, there we consider the theory of probability. In that case, every time whenever given input, it will give the relative probability of the outputs. So it means the output will change every time whenever uncertain input is there. In deterministic model itself, data-driven models are there, parametric models are there, and the mechanistic models are there. So I will not take much. I'll not go much into the metric, parametric, and the mechanistic models. I think it must have been covered in the previous lectures. So presently we'll be going for the a bit of semi-distributed model and the stochastic. Stochastic models. We're not gonna touch those parts because those models are usually used when certain predictions supposed to be done with certain accuracy. But equally, deterministic models are also good. In that case, we will be developing a lumped, conceptual, and semi-distributed models. So this is where the HECHMS falls in. Okay. So coming to the HECHMS model, what exactly HECHMS is? The Hydrologic Engineers Center's Hydrologic Modeling System. So it is developed by US Army Corps, and you can download using the site given. So what are the basic? Whenever you see the HECHMS, what exactly you see? Okay, so whenever you see the, I got a message to on the video. Just I'm on the video. Wait, so can I set my mobile properly? Okay. Yep. So whenever you see the HECHMS, I hope everyone has installed HECHMS. Can anyone confirm the installation of HECHMS? You can text me there. You can text me if you thought you guys have installed HECHMS. So I'm checking your text messages and
Yeah. Sir, in chat box, they have written yes, yes.
okay,
Most of the participants have installed. Yeah, it's good.
okay, fine. Yeah, it's really good. So we install once you might have seen, this is the first window what you see when you open. You don't see this. This you'll see this is a black screen. Okay, but in general you see these three windows. Where first window is the watershed. Uh, Watershed Explorer, where we actually create our basin, and in the watershed viewer we exactly see what exactly we are going to and what's we're falling. And then in component editor, component means whatever the watershed basins we have created, in component editor we can give those inputs, like whatever the values we want to assign, those values we can assign in the component editor. These are three basic models you see. So it's simply you see here, I'm just demonstrating here. So this is where we create the basin. You see the basin models, and then we create all the components of that. Suppose I want to give certain values of those, then I'll click here. So whole this window will appear down here, and here using this I can give the values of those, and then I'll see like whichever basin have been selected, you can it is highlighted here also in screen. So this is the basic commands, and whatever the error I get, whatever the message I get on this screen. So this is a execution command window. So coming to the next, so I'll just take a brief introduction to the how exactly rainfall model takes place, like happens, what equations are, what are the equations governs there, and what are the major components you have to consider, or how to have the data of those to develop a hydrologic model. So in general, if at all you want to see, you want to develop a model, you must know how exactly this phenomena is happening. Once if you understand how the phenomena is happening, then you can understand how exactly you can model it, right? Before developing any models, you must know how this phenomena takes place and what are the different parameters of those parameters to govern which makes it to occur those phenomena. And then we should have those parameter data, then only we can have the model. So in general, this hydrologic model means we're exactly trying to simulate hydrologic cycle. So in that case, we should know what is the vegetation cover, what are the land surfaces there, and then what are the different water bodies. So whenever precipitation happens, it happens on these three different locations. On the vegetation, it can be on the direct on the land surface, on the water bodies. So whatever the rainfall occurs, that might get evaporated if it is on the land surfaces or the water body, or if it is falling on the vegetation, it can happen and it can evaporate. It can evaporate also. It can have the it can do the transpiration also. These are the losses. Which
Sorry to interrupt you. Please bring your
yes.
presentation on presentation mode, sir.
Yeah.
Okay, yeah. Thank you.
So in general, suppose and then we must know what are the soil characteristics are there, which will have the loss as well as the base flow transmission to this stream channels. So these are the basic idea, like there is some evaporation is going on, there is some losses also going on, there is some zipper soil strata is there. So we have to include all those in our model so that model will be robust and a complete representation of the system, right? So then what exactly is the methodology, right? How exactly this rainfall runoff model can be done? What are different steps we have to follow? I have put simple flow diagram to understand a complete methodology of developing HEC-HMS model or hydrologic model using HEC-HMS. So it starts with the data collection. First, what all data I have, we should have, like one should be, we should have rainfall data. Rainfall data means it depends on what kind of model you want to develop. It can be an event-based rainfall, or it can be a continuous rainfall, continuous RR model. So in event-based rainfall, we actually see how the we simulate a particular event, and then in continuous modeling we consider the long period of the rainfall data, and then we simulate the entire period, and we see what are the different changes or what are the effects happening on the watershed. Okay, so in that case, we actually the data, what kind of data we want actually depends on what kind of model we are interested in. So apart from that, then runoff data. Runoff data is very much important because rainfall data nowadays is easily available. It can be, you can access from RCM model, GCM models. You can even IMD has given free data to everyone. So rainfall data is not an issue nowadays. The problem is the discharge data, and mostly nowadays discharge data is also available from Waris website of India. The thing is, there are so many missing data is also there as my experience. So you might get over some basins there must be a good data, and then there is a lot of like I won't tell like what exactly what kind of quality of data it is. So quality is been seen relatively very poor there. That's why you have to procure the data from the state water agencies or the CWC, like that. So then only you'll have a good quality data, because ultimately whatever the model you develop, that whenever you give an input, definitely it will give a certain output, right? So it should make sense. Even nowadays such a techniques are developed where we can match also, like suppose there is certain rainfall and you have the relatively very poor quality run of data, we can match those data using calibration validation techniques. Such advanced techniques also came up. The thing is, that's why ultimately that what's happening inside, you must understand that, and then you should have a quality data to understand the complete response of the catchment for the given rainfall. This is what the definition of the hydrograph, right? So how the catchment responds for the given, all the questions will be taken after certain time. So I'm just focusing on, I will continue to the HECHMS because this is a 2-hour lecture, and if at all I have to cover the hands-on of that, then we have to move faster. Sure. So Deepesh, I will take your questions later on. We'll definitely discuss. We have whole day, but within a schedule, I try to finish the HECHMS modeling. Okay. So then the topographic images. These topographic images are used for delineating the basins. Just for information, we can download nowadays India One website or Earth Explorer US websites are giving free data for TM, having 30-meter spatial spatial resolutions. So using those data, we can delineate the basin, and then those basin delineated, we can have an input to the HECHMS. You must understand, HECHMS doesn't consider any of the basin delineation parameters in its modeling. It's just the representation in the background. It doesn't have anything to do with its own basin delineation parameters like other model does. Like suppose you consider the SWOT, it has to do with something to do with its delineation basin. But here in HECHMS, it's just a background image. Means you have to visualize completely of your modeling of your area, and then only you have to come to your simulations, your analysis part. Then in that, again, there are so many steps are there, like you have to create the basin, you have to give the loss methods and the meteorological model you have to define, you have to import the data series and the control specs, and you have to do model simulation. All these steps will be covered in the further slides. After, suppose you have done the modeling, it will simulate. Okay, you will simulate the model. That's not a problem. The problem here is how can you fit those data or the model parameters which will give the reliable output, right? Suppose you have a certain discharge data, and whenever you give a rainfall, there should be a relation between these two parameters, but it won't match in general. Why? Because then again, there are so many other parameters are governing. Suppose you consider the soil parameters. There you have the input of what is the infiltration rate, what is the initial content of the water, so what is the saturation content, what is the conductivity of it. So though, and plus there are so many other parameters like lag parameters are there, like basin lag parameter is there, which will also governs the relationship matching, fitting to the rainfall and the discharge. That's why after developing then your a complete model, you have to understand what exactly the parameters to be used, because even you estimate the in general, if you discuss, suppose you are having suppose you are went to the catchment or basin to visit, and if you measure the infiltration at one place and then you went to other places, do you think that there will be this, there you will get the very same infiltration rate? No, right? That is the reason why in lump models this will be an issue, because in lump models are totally or averaging it. So that's why careful using of those parameters are very much important. In the distributor, semi-distributor models, in semi-distributor models, like we consider small basins, and there we define again there is a small there is intrusion of the lumping, but not much as lump modeling. So we should be careful enough to give the proper parameters. But of course, the exact estimation will be difficult. That is the reason why we should go for uncertain analysis or model calibration and validation. So, okay, as for the how much data we should consider the calibration and how much should we use for validation, all have been discussed earlier, I guess. So I'll not put much talk on that. So again, basin delineation means like how exactly you can delineate the basin. So that part is like not so important for the HECHMS. That's why I'm not covering that part, and that part will be covered in your SWOT modeling. So in HECHMS, that is not so important, because as I said earlier, in HECHMS, whatever the figure you put, either shapefile or any image you put, that just takes as a background image, nothing to do with your modeling concepts. That's why I'm just avoiding that part. But how we can do that, I'm showing it on the screen. So in the Arcmap, this most of the studies are like what I'm showing through is HECHMS only, and then Arcmap. So in Arcmap, if suppose you open the toolbox, there you can open this spatial analysis tool. In that hydrology, you can see all the hydrological tools like basin, fill, flow accumulation, flow direction, and the other options. So you can simulate, we can delineate the basin. So mainly fill, why we do is like fill we do for if there is any outlier present in the DEM. Suppose in DEM the elevation is certain position is maybe erroneous. That's why when you do the fill, it will eliminate those this thing. Yeah, of course, this is showing the Artisan polygons. Why I have shown the Artisan polygon, I'll explain it. Right now, I have not shown the basin delineation, so I will include all the figures. Basin delineation not so important, that's why I'm excluding that part. Okay. So this is ultimately when you do the basin delineation, you will get this kind of figure of the basin, and then I had to locate the different whatever the gauging stations are there. So whenever you collect the data, maybe the grid data or maybe the gauging sites, you will have the lat launch of those. So you can using Arcmap, you can locate those all the gauging sites, and then after locating the gauging sites, I have to create a Artisan polygon. Why Artisan polygon? I'm asking you to create, because just imagine the rainfall gauge is distributed over the entire catchment. There can be many gauging sites, right? And then the parameter can also vary from spatial, it can vary. So what we can do is using Artisan polygon, we can create a certain sub-basins, so that certain gauge will be fixed to that gauging sub-basin, and then we can assign those parameter values of that particular sub-basin. Means suppose there can be different soil at other places, like suppose you have the soil of black cotton soil, maybe in downstream and upstream there can be a different kind of soil. So in that case, we have the flexibility to define different parameters if you consider the sub-basin. So that's the reason why simply if you can create Artisan polygons spatially, so it will you will have this kind of semi-distributed, not completely semi-distributed, between lump and semi-distributed kind of model you can create. So first of all, you create Artisan. How you create the Artisan polygon? Just in Arcmap, you just search a Artisan. You'll create Artisan, and whatever the point shape file you have created earlier, just give that input. Then it will create the Artisan polygon like it's shown on the figure on the screen. So once if you create this Artisan polygon, means this will be our sub-basins for the entire catchment of whatever the interested study area. So then we should understand what are the different components are there. Like suppose I'm doing HECHMS, so I must understand what are these things are there, right? Means these things, what these exactly represent. Because before I'm coming here, I'm showing you what are the different options available. Once you understand, then you can directly come to the modeling part. Okay, so I'll take 5 more minutes to explain all these components of this HECHMS, and then we'll exactly start doing hands-on. Okay, so I'm going to explain what are these parameters, or sorry, these components of this HECHMS, and these are the very much important components of the HECHMS. Using this only we create the basins, sub-basins, and their parameters, and we actually create the basin on the computer using these things. So how to create means what are these components represents, that's I'm going to explain now. Okay. So this this parameters, the image what it shows is sub-basin. Means there you whatever rainfall you give there, it is your computation is happening. Whatever the rainfall you are giving, there only the runoff computation is happening. Suppose so as I said earlier, we have created a Artisan polygon, right? Simple Artisan polygons we have created for the entire sub-basin. So now what I will say is, this is my complete watershed or basin, this is my sub-basin. Okay, and then I can say this is the sub-basin like this. If I click like this and if I place here, it will create a sub-basin. Suppose I click here, I click here. So this is just, it will ask for the name. When you create the name, it will, you can fill it. We'll practice hands-on just after a few moments. So whatsoever computation is happening, whatever the rainfall are you giving, there it is the computation is happening. Okay, that's the first thing. And second thing is a river reach. River reach means, suppose this sub-basin has computed a rainfall, but how to carry to the outlets, right? That there should be some means to carry these rainfall computed here to the downstream. So using the help of the reach sections, we bring this rainfall computed to the somewhere junctions or the downstream points. Okay, after that, so after this we will be having a reservoir. So reservoir, suppose there can be a reservoir in your basin, right? Then it will have some storage, and thus if there is a storage, and that definitely going to affect on your hydrograph, right? So that is the reason why we must know HECHMS is different from SWOT model. Which one gives better result? This question was asked. Okay, I'll just answer this question. Somebody has asked, Vishal K. English has asked the HECHMS is, how HECHMS is different from SWOT model. I'll take a small pause and I'll explain this. See, HECHMS is lumped and a semi-distributed model, and the SWOT is a completely semi-distributed model. The difference here is in SWOT model, it has a complete water balance equation. It can complete water balance equations. Based on that, you can develop a complete model. In HECHMS, it's a very simple model. You know, many of the models are in this software or the tool are mainly the empirical equations. Like you might have known the Snyder equations, maybe known the SES curve numbers, likewise. So all these are the very empirical equations, and this is what the capability of the HECHMS. SWOT model is a semi-distributed model. So there you can do the comprehensive hydrologic models. But yeah, of course, but you know, suppose you have a choice, like you want to use for HECHMS or SWOT model, you can have a choice in between. Of course, HECHMS also gives the better results, but HECHMS makes your hydrologic simulation very simpler than SWOT, because SWOT requires a lot of data as compared to HECHMS. So when you say which one is better, I'll say both are better in their respective use. Right? Suppose you want to use HECHMS for a different kind of analysis, what you want to carry on. In that case, such a huge software you don't want to use in that case. So you want to just simply go HECHMS, and you can understand so many basin characteristics. In that case, you use HECHMS and SWOT model. Of course, they have the different capabilities when you simulate. Of course, they have the different results, but they are different in both the cases. So it depends on your complete analysis, what kind of analysis you want to carry on. And in that case, you use SWOT or HECHMS.
Yeah, excuse me, sir. Sir, we will take all this question after at the end of session. So you please carry on presentation and demonstration. We will have separate question and answer session at the end of this session. Okay.
Okay, no problem.
Yeah,
No problem.
I request all the participants will taking the question and answer session at the end of this session. So it is convenient to both speaker and participant.
Sure. So we'll take all the questions at the end. Yeah. So HECHMS is also ultimately HECHMS is a good model. You can use it for your kind of analysis you want to carry on. Okay. So after that, you see here after this understanding, this is a sub-basin, this is the like where is competition happening, this is a reach where how you carry out how you want to transfer this computed rainfall to the downstream. We use the reach, and then the reservoir. If there is any reservoir in the your catchment, you can use this because that will affect your hydrograph, because that will store certain huge amount of water obviously, and it will affect your hydrograph. So that's why you can have the reservoir. And these are the junction creation tool. Junction creation tool means, suppose you want to combine like outflow of the 2-3 basins. So you can see the icon here, or how it's shown here is there is a discharge coming inside and is going out. Means it will not store, it will just transfer the outflow from whatever the inflow is coming. So this combines the flow from the upstream reaches or sub-basin. So you want to combine there somewhere. You want to have you want to see whatever the amount of how the hydrograph is there at that particular location in mid of somewhere in your basins. Like suppose you want to see here, these 2-3 sub-basins are coming here and joining here. I can join here, and then I can create a complete your junction. Okay, so in that case I can complete it. And you want to, whenever you want to validate also, suppose I have known discharge data at this point. Suppose I have known discharge data at this point. I mean, in that case, I'll create a junction. Okay, then I'll combine whichever the sub-basin is going to come at that contributing at that particular point, and then I can put the discharge data, and then I can combine whatever the computation is happening plus our observed data, and that will be that will be taken or acts as the your point of calibration validation. So that's also junctions are helpful in that way. So you just see here the diversion tool. Diversion tool means if there is a rainfall, the rainfall happened from the sub-basins, you can divert certain amount of water if there is a certain loss, which is not coming in the junction or in the contributing sub-basins. Suppose in the river, this certain river might flow like this outside. So this is not combining into this one. So we can have this kind of diversion tool also. Okay, this is a source. Source creation tool means if there is an addition of the stream somewhere from the upstream of something is coming into this sub-basin, then we can create the source stream. Source means you can add certain discharge into this so that it will carry an additional discharge without computation. Okay, so this is sink, means the water is not going to come out. Just see the icon of how it is shown. Sink. When you see the sink, there is say like source. It has like there is certain water stored and it will sink. Outlet will come, like water will come out of this sink source. But in sink, we can see this completely blocked. Means whatever the rainfall goes, it will store. It will not discharge in the downstream direction. So the sink, whenever there is a sink, means there is a certain amount of water going to be stored in somewhere. So you can create a sink. Sink can be empty reservoirs also. Okay. So after understanding, if you understand this one, like this is the like sub-basin creation tool, reach and everything. So then we can create a complete sub-basin. Okay. So sub-basin, we'll create the sub-basin, and I request everyone to start practicing with me so that it will be complete understanding of your this thing. So I'll just open HECHMS in new folder, like a new file. So everyone please open the HECHMS. Okay, whenever you open this HECHMS, this screen will appear. There is nothing is there, right? So first, I guess I have to take some questions here. There must be somebody must be facing. Can we use HECHMS model for canal command area? Yes, you can use anywhere. Like if you think, see, the thing is like how to get soil data for western part of Maharashtra. Is it free? Soil data, whenever soil data I have the complete slide for the soil data and the data actually. So we'll discuss there. Of course, you will get the soil data freely. That is from FAO. Like FAO, if you go to the website, you can freely get the soil data. No. Pardon me. So please provide sample data if possible. Yes, I will definitely provide the complete RR model. Okay, I will give you the link. You can download from there. But right now, you just practice with me so that you don't have to use those, open that model and get confused with everything. Okay, that's why I'm not given you. I'll give you the complete model. So let's start practicing this. So whenever you open this, what I'll say is like, I'll create a new model. Okay, I'll just say new and then I'll say name. So like Rahuri training practice 1. Okay, I can have description. This is like training model. So and then wherever I want to store, I can direct it to the store. Suppose I want to store somewhere else. Suppose in I'll store. I can direct it to wherever I want to store. So I'll just store somewhere. I'm working here. So just for a practice, I'm doing it. So I'll just say HECHMS practice. Okay. Pardon me for the okay. I'll just select here and create. So now I have just created a complete setup, means a model, a project I have created. Now I have to add a basin model. Okay, this basin is, suppose, or as I was explaining you earlier, this basin I had to add, not the sub basins. Okay, this basins I have to add. So in that case, I'll create new sub basin. I'll say we are taking an example of lower Tapi basin. So I'll say lower Tapi basin. Okay, and then I'll say here description is you can keep this empty also if you don't have any description. RR model of lower Tapi basin. Okay, and I'll say create. So this is just created and just see here. So this window got appeared. So earlier we were having nothing. Now this window is coming. So there we can add our sub basins. Okay. Okay. So what I will do is I will share you with the some watershed data. Okay. Before that, I'll just show you how exactly you do. I'll just say add map layer. Then I'll say add, and then I'll direct to the Artisan polygons I have created. As I shown earlier, how to create these polygons means like we can have the complete point shape files of those. Once you have the point shape files, you can create the Artisan using Arcmap, and then this was the output of those, and this is where I am taking as an Artisan polygon select. I'll say select.
It is request from participant. Please go slower, slightly slower.
Okay, fine.
Yeah. Can you please repeat the procedure? Actually,
yeah, sure.
Yeah,
I'll repeat it. Sir, it's very fast, slower, sir. Okay, fine. So what I did is now I'm creating a basin, right? I'm just adding this. As I said earlier, this is just a background image, nothing to do with your actual simulations. Fine. So we are just adding a sub basin, a background image, I'm saying. Okay. So what I did first I created a new project. I said new, and I created I created a new project. After that creating new project, I created basin model manager. Okay. So when I click this one, there is already LTB is there because I just created website showing here. I just say new, and then I can create one more basin using this. And I say and say create. It will create like this. It will show up here and like this. So this, as soon as this comes, this will appear like this in the screen. I'll have to click on this plus, expand it. When I click on this window will appear. So this empty window will appear. Fine. So once if this window appears, then what I used to say, I will share you the first the shape file. Kalpe sir, where sharing the files?
Yes, sir. Hello.
Where are we sharing the files? Is there any particular location where I can directly put?
In chat box.
Okay.
Yeah.
Okay, there is an issue with this thing. Sure, so I'll just compress to what? Compress at so I just created this thing. I'll just share with you. In chat box, I can't add the. Can it possible to share the files? I don't think so. This is just a chat box.
Otherwise, do one thing, sir. Do add on that expert group, or otherwise link on your mail. We'll share on the Google Drive.
Okay, I'll share through the mail. You just share with them.
Yeah.
Okay.
Give access to download from Google Drive, so all the participants can able to download that thing.
You only share if there is any some common platform. I'm just sending you. Until then, I will demonstrate. Okay. Okay, so I have shared you. Kalpesh sir will share with you that data. Okay. So what next step is? I'll just create right click on this and add map layer. Map layer, as I said, it will be just a background layer, nothing to do with your actual simulation. So I'll say add, and I'll select these. As I say, the soon you get, you will have this shape files. So I'll say add these in polygon, and I'll say select. Okay. So when I just say select, it has just added the complete subbasin and these polygons of the subbasins. Now I'll not go for the entire subbasin, because that will be like it will take a lot of time. But I have complete model that also I will share with you the entire model while simulating. I'll show you the simple example, and then while simulating, we'll simulate the entire subbasin what I shared. Okay, so even if you do not have right now, that is okay, because this is just a representation. So even if you do not have, that is okay, because that doesn't take account in any computation. So that's fine. You just follow me, and even if you don't add this thing, that's fine. It's okay. Fine. So I'll just say, I'll just create subbasins here, like these three subbasins I'll create. This one subbasin. So I'll say subbasin. I'll just name it as like subbasin only. Leave it subbasin only. If sometimes you can name it as your gauging site also, because the certain subbasin will have, it is necessary to add only Thissen polygon or shape file. Yeah, of course you can add any. Of course, Thissen, if at all you are adding Thissen polygons, it will be very convenient to understand or visualize your subbasins. If you do not add the Thissen polygon, suppose if I say, okay, I'll just say map layer, and I'll just remove this one, and I'll say add, and I'll just add new shape file, lower tab basin. So select. See, there is no Thissen polygons here, right? So in that case, I have to visualize. This is where the subbasin, first subbasin is coming. This is second, and this is where the third subbasin is coming. So the visualization will be a bit complicated. And one more thing, the question is like, how can you select later on your subbasin area, right? So Thissen polygon will come in handy in that case, because whenever you have subbasin means you should have area also, right? So in that case, it will be very difficult. Okay, so that's why. So if this is a gauging station, one gauging station, how much area is influencing here is most important for computing your rainfall. So suppose you are considering rainfall here and computing considering rainfall here, rain gauge here, and computing for this over entire area makes any sense? No, right? Because hardly the influence will be within like 5 to 10 kilometers radius. So if that is there, then that's fine. But it's going beyond that. Then in this here in this area, there might not have been rainfall, and you're unnecessarily accumulating. Unnecessarily you are giving the rainfall over there. So this empty area, this non-rainy area will contribute unnecessarily rainfall and runoff. and that will add an error into your modeling. Suppose we have only one rain gauging station in entire watershed, how we will create the polygon? And no need to create. Why want to create the polygon if there is only one rain gauge? And don't go for one watershed if there is only one gauging station in entire watershed, because that will be complete lump model. You just compute the rainfall directly, use the empirical models and compute the discharge. Okay, in that case, you don't have to go for this HECHMS or whole complete modeling, because this makes no sense in that case. Okay, simply rain gauge means you just compute the rainfall, and then direct relationship you can compute the discharges. So no use of that. That's why there is a condition for that. If there is certain area, you might have known how much minimum rain gauge stations should be there in my area to satisfy the requirement of rain gauge stations. That computation should be done before. And you might have already known this, this problem you might have solved in your graduations, where you how much if this is certain area and these many gauging stations are there, whether it is sufficient or not. That computation you first do and then come here and then you start do the modeling. If there is a insufficient, then the model will not give any error. You will definitely have and complete this thing. Okay, so data has been shared. You can have the you can download from the link. So I mean, what I'm discussing is, if at all you do not have that, then making that making modeling will not have any a meaning, right? So the first you should have to justify around a sufficient number of your engage stations, and then only you come here and do the modeling. So then of course you can follow the rest of the procedures. Okay, so here what I'm assuming is each and every Artisan polygon has one gauging stations. That's very much important, because I have considered the influence of the each and every gauging stations, and within that only I'm creating a subbasin means I'll have very less error in my area which is not contributing to the shared map has been successfully imported to HECHMS. Wow, good. So that is fine. If it is created, then I'll just go to the next point. I hope everyone has understood. Listen, understand. Even if this you do not have this shape file, that is okay, because HECHMS has to do nothing to it. Is there any other way? Yes, of course, there is an other way also. You can use HECHMS. Okay, when you have HECHMS, in that you can delineate the basin, and then it will directly import to your the HECHMS model. But we are not using the Arcmap, that's why I'm directly showing in the HECHMS. So the simple step, don't get like confused with this model. This is the least important in your entire modeling. That's why I'm not giving much importance, but it is very easy for your it is just for your convenient to understand and visualize your watershed. That's it. Okay, let's move on to the next thing. Once you have this this subbasins, then I'll add this the polygons, Artisan polygons. I'll add the subbasins. I'll create, and I'll just say I can name it as it is I want, and say create. I have created one subbasin. Likewise, suppose I'm just creating 3 subbasins here. Create. I have created this thing and this thing. So I just created 3 subbasins. You can name as you want, but I have just named it as subbasin 1, 2, 3. Fine. So these are my subbasins. Why I'm not considering, because I have complete model. I'll share with those that complete model. We'll simulate that later on. Just understand the procedure right now. Later on we'll simulate. Okay. Okay. So once you create these 3 subbasins, then what I want is this discharge has to come to somewhere in the junction. This somewhere in the outlet point, right? So what I will create, I'll have one junction. These 3 subbasins are contributing at this point. So I'll just create one junction. Okay. Then how can I bring this junction, this discharge to this junction? For that, what I want, I should have how add. What was the question? How add WRR file in HMS? Right now, you just focus on shape file.
Yeah, actually, you have to unzip that RAR file. Actually, it is RAR file. You have to extract here that file, and then you have to add that map place.
Okay, RAR file, you have to have like RAR files. There is some other format of the files. I was thinking that RAR files is just extract it. In that there is a shape file. You have to add that shape file. Okay. So I hope everyone has extracted that and added the shape file. Even if it not added, that's fine. It's okay, because you can understand it later on. Just the thing is like once you extract it, you can just simply add the layer. Once if you have done these 3 things, means simply I'm explaining these are 3 subbasins. Step to add HMS, please repeat. Okay, I'll just repeat for you once. So I'll just say select map layer and just say add direct to the file and just say select, and when you say select, it will come here and it will show up here. That's it, the simple question. Okay, once we understood this thing, so okay, come to the point where we have now 3 subbasins created and the 1 junction. Why the junction is? Because these subbasins are contributing at this location, means this is acting as an outlet, and I know the discharge at this point to calibrate my discharge data. Fine. So if that is the case, then I have to bring this discharge to this point. I have to have a reaches to join the discharge from here to here. So I'll just say I'll click on this subbasins and then I'll draw a line connecting to this point. So and I'll say reach 1. Okay, and I'll say this reach 2 and reach. I'm just clicking on that and nothing doing on not without clicking anything on the mouse. I'm just dragging and bringing on the clicking on the junction 1. So I create reach and select create. Listen, see, when I move, it didn't move. You must notice that whenever I'm moving this one, it is not moving, right? It means what? This connection is just pictorially represented. Nothing is now, nothing physically in this screen is connected now. We have to connect somewhere else. Okay, this is just a pictorial representation here and nothing to do with your actual modeling. Okay, that's why this is here on this window, everything is pictorial, nothing else. Okay, so now I have created my 3 subbasins, 3 reaches and 1 junctions. Why I have created, you must understand. Subbasin means whatever the rainfall wherever the rain gauging stations are there, at every rain gauging station I have created with Artisan Polygon so that there won't be any excess rainfall computed. And then these subbasins, then I have connected using reaches to the junction where I know the discharge, or this is the outlet discharge measuring location, and then the reaches will be delivering the discharge to this junction. Okay, so when I expand this one, I have whatever I've created, I will see here. Whatever options I've created, all these things can be seen here. Okay, once if I click on this, then whole modeling concept will start. It starts from I have to give an what is the downstream of this. So this subbasin is there. What is the downstream to this? Can anybody tell? You can text me on the chat box. What is the downstream to the subbasin? Okay. Okay, I'll just check the chat box. So, sir, all streams are not meeting at junction. Not necessarily. Suppose see, subbasin, some subbasin might not contributing to here. Some might delivering discharge this one towards outside of this basin. So in that case, you don't have to connect. But in this case, in this river gauging stations, all these things are because this is downstream and this is a watershed. So this portion may not contribute because this might deliver directly to the discharge towards this point. But all these stations will be delivering like this. So I'll just add one more layer. I'll show you why I'm talking like this. Tapi river and I add. Okay, and I'll say draw properties and I'll just change some styles. I'll say increase the weight. I'll just say this red and say apply. Okay, can you see the river now? This is the river. Means these all the subbasins are contributing in this river, and this river is carrying the discharge and delivering at this point. So this acts as a junction, right? So that's why I'm creating the junction. If that is not adding, it's like you are a decision maker, right? You have to take the decisions where if whether this subbasins it is like contributing discharge at this point or not. But that we can understand through using DM, right? So once you have the DM, we can understand the subbasin and then how to delete any components from the subbasin. Okay, if suppose you have an extra added subbasin, then come here, right click here and say delete. So when you say delete, it will just delete. And when you say like again one more time, you can create and you can add it. You can rename also from here. You can rename also. So you can like move up and down. That's just simply can using the click mouse you can move also. Okay. So now what we have done is we have created this subbasin, 3 reaches and the 1 junction. Now we will see what are the different subbasin is there and what are the things we have to consider, we have to understand for adding the river, creating the river simulation. First of all, when I click this one, this is subbasin 1. So here name also comes element sub-basin 1, basin name is lower Tapi basin. So here downstream to this means sub-basin downstream is which junction it is. Whenever click on this is a reach 1. Okay, so I should know reach sub-basin 1 and reach 1, sub-basin 2, and this is the reach 3, sub-basin 3 and the reach 2. Okay, so sub-basin 1. So if this in the sub-basin 1, the downstream is the reach 1. I made the reach 1. Okay, I hope everyone understood. Okay, so for the sub-basin 1, the downstream to this sub-basin 1 is reach 1, which is carrying discharge to the junction 1. To the sub-basin 2, what is the question? Not to outlet. Okay, what you Pandurang, what you want to ask? I didn't get you. Not to outlet or what? What do you want to ask? And understand your question. Okay, so once if you create sub-basin 2, and then we have the junction sub-basin 2. There is a reach 3 is to the downstream, and the sub-basin 3 second reach. Okay, so you can click sub-basin 1, sub-basin 3, junction 1, sub-basin 1, reach 1, and then reach 2, and then I'll click on junctions. Okay, sub-basin 1, reach 1, sub-basin 3, reach 2, sub-basin 2, and reach 3. So it can like it cannot be like it's not necessarily it should follow numbering same. So that is fine even if it is mixes up. Okay. So now we are like sub-basin 1 in downstream to this is reach 1, sub-basin 3 reaches 2, and then sub-basin 2 and its reach is 3. So now we have assigned whatever the downstreams are there. Okay. Now I'll go to sub-basin 1, then I'll add other components. So here I'll just open. Here I have computed the area. How you get the area? Once you create your this thing, once you have your complete Artisan polygons, just I'm showing you the exact what exactly I'm trying to show. Okay, so once if at all you have the shape file, this is the shape file, and then I created the Artisan polygon like this. Once you create the Artisan polygon, then you directly will get the area. When you open attribute table, you have the area. Okay, so or else even if you do not have the area, you can add the field. Okay, you can add the field and you can compute the area. I'll not show this part. This part is like it will take so much of time. So I'll just say imagine like you have computed the area for the each sub-basins. Okay, Artisan polygons. So likewise after computation, I just exported into the Excel sheet. Okay, you can just for example it is you can add random area also, no issues. So once you add the area for the we are talking about only sub-basin 1 now. We'll talk only about the sub-basin 1. Okay, then I'll say area is around reported area around 125 kilometers. Okay, sub-basin 2 area is around. I'll just finish sub-basin 1 everything all the part. So sub-basin 1 area is 120 square kilometer, and then here we have to define loss method, transform method, and base flow method. These three are not important when you are considering the simple non-gridded modeling. So when you do the gridded modeling, these three things will come. A canopy is like the canopy means whenever there is a surface area of the vegetation that will intercept the water. In that case, you can consider the canopy. So I have just explanation for those three parameters. Okay, so I'll just explain from here what are these things. Okay, means canopy method, surface method, loss method, transfer method, and base flow methods. How to assign the values, like how to get those values and give the assign those values. Okay, so from here we'll just open this component we have finished. SubBasin we did. Next is the suppose we are considering certain gauging station. There we'll be having, we should know the downstream. First thing is we have to define the downstream, whatever the downstream it is there. Next is the area we have to define. Next is canopy method, and next is surface method, loss method, transfer method, and base flow methods. Okay, so let's come to the canopy. Canopy means whatever the water falling on the vegetations that will intercept that water, and then that will contribute in the evaporation. So that may not, that acts as a loss also. So that's why we must know canopy, and the canopy loss is very small. That's why many of the times it is said ignored, right? Canopy is very little, so that's why we most of the time we ignore also. If you want to consider, then these are the three different methods: simple canopy, gridded canopy, and dynamic canopy. So when you have the a simple canopy means we must know what is the percentage it can store. In canopy, you can have the vegetations, and on the vegetations you can estimate how much percentage it can be stored, and then what is the maximum storages. So these all things are like uncertain values, right? In a watershed area, computing canopy is simple. Like we can use like GIS and remote sensing and compute the canopy. But what is the initial storage, maximum storage computation will be having uncertainty. That's why, and that's also, these are very little values. So unnecessarily including those in the model will be complicated. That's why it's better to avoid the canopy if at all you are considering for the a small, very short duration rainfall. If you are considering for the long duration rainfall, in that case, you to have the canopies. So generally, only they are used only continuous simulation applications. For event-based simulations, we don't consider the canopy loss. So surface methods. The surface methods means it intended to represent the ground surface where water may be accumulated in surface depression storage. Okay. So as I said here, there is a surface method. This is the surface method. So surface means if there is any storage is happening, like small ditches are there on the in the watershed, want to represent that small ditches. Okay, the reservoirs we have created using this thing. So if in the watershed if there is undulation or something which is like storing certain amount of water, if at all you have the idea about that, you can use those surface method. But again, that is also very small amount as compared to the whole system. That's why we ignore many of the times. In that also there is a simple method and gridded method. Simple method means like we just create one subbasin or two or three using surface method, and then we just give the what is initial storage and maximum storage. And then gridded means if you are having the HECHMS model in gridded at grid stage, grid level, there we create the complete gridded model. And gridded at each and every grid we can assign those surface storages. But these canopy and surface usually we ignore because this storage is very small as compared to your actual runoff occurring, so doesn't affect much to our model, so we ignore those two. So coming to the loss methods, this is very much important. Why? Loss is ultimately whenever the rainfall occurs, then there is the two types of losses occurring apart from the your interception losses. One is the infiltration loss, and next is the evapotranspiration loss and your evaporation loss. So these two things has to be accounted very much, and this is where this is the actual computation is happening on the subbasin. So it provides you the total 11 methods. Okay, for selecting loss methods. In the 11 methods for India, or for mostly in Indian regions, as for my research also, we have to publish a paper on this. Green-amped and the SCS curve number loss methods are suits better than other methods. Of course, you can calibrate and you can fit those any of the loss methods, but with simple data, with less minimal data, you can fit to the most of the Indian base subbasins. Green-amped loss and the SCS curve number. Suppose green-amped, suppose you consider the green-amped, okay, SCS curve number means you have to have only curve number, but when you consider the green-amped, so their parameters how to get. Okay, so many parameters when you consider the green-amped. Suppose if I say here, so loss method I say green-amped, I said as. When I say loss method, I just added loss. I should have initial content, saturated content, suction head, conductivity, and imperviousness. Okay, all three, four things should be there in my for this subbasin. I should have the knowledge of all three values. Anybody has any questions? Let me know. Sir, if subbasin 1 is not having any reach that connects to the outlet directly, but rather reach 1 joins the reach 2 from the subbasin. Okay, in that case, what you want to say is, okay, I understood your question. From subbasin 2, how do we do that? Okay, the here's Shivan Stivar has asked one question, very good question. The thing is, suppose you are having a subbasin, like this is the subbasin here, like junction outlet here. So what I will do is, what he is asking is, suppose these two basins are contributing here, and this is separately connecting this one. So what I'll say, I'll create one more junction here. Okay, what I will do is, then I will just say delete. I'll delete. I'll say delete. This junction will come here. These reaches will join to this one. And then I can join this junction to this junction. So this junction, it came here to this junction. Junction 2 is going to junction 1, and this subbasin can be added here like this. So if there is like, if there is a long river, suppose this is like this is a very long river, right? In that case, we will be having so many subbasins, right? So they like, here's one subbasin, here subbasin, and here everywhere subbasin will be there. So in that case, what I will do is, I will just create junction in between here, and I'll add these reaches, this location here, and this here. Once I do this, so I can connect this, and later on I can create this reach and I can connect to here. So likewise, you can have the multiple junctions to connect different subbasins. Sir, suppose Mahesh has asked one more question. Sir, suppose some of the runoff from subbasin 1. Sir, suppose some of the runoff from subbasin 1 is getting outside of the boundary catchment extent through the pump or lake tapping, and only control flow from the subbasin 1 joins to our sink. How can you represent it in our model? Yeah, of course, if there is anything was going out of your basin and certain amount is adding, then you can, as I said earlier, this, okay, you can create a diversion tool. So that diversion will certain amount of discharge will divert towards wherever you are diverting out of your basins, and then you can add discharge also. Diversion means there is some addition also in that, and then that we can connect here. So if I say this diversion tool means this certain amount of discharge completed from here is going out, right? Somewhere diverted means it's not adding to into this one, and then certain and later rest of the discharge will going to add. So that's how we can create that way. I'll not add these parts. Okay, so you can have, there is so many possibilities, and you can, using these tools only, you can create entire model, but is that you should have an proper visualization of your entire basins. Thank you, got it, sir. Okay, so I'll just delete all these things. Okay, important. Okay, no issues. So I have made already one thing here, one more model here. Okay, so this is a start. This is from where we said. I'll just say I'll not touch this model because it's already messed up. Okay, once if you created this one, then I have to assign the parameters for each and every subbasins. Okay, so I'll come to subbasin 1. Okay, this is subbasin 1, and then I had to see, when you expand this, you will have options expanded. In this case, the same option is appearing here also in this screen. Okay, so now what I will do is, I'll just consider SES curve number is a loss method, SES in hydrography is the transform method, and I'll say there is no base flow. So base flow, there are so many techniques, but usually, like if you can compute this, you have the base flow, or you can compute the base flow. You can say a constant monthly. Generally, for the certain basins, if you have the base flow, like computed base flow, then you usually compute monthly average, and then that directly input you can give. But if this is like, if your rainfall RR model is an event-based rainfall, which means you are considering for a small duration rainfall, in that case base flow is also doesn't play any role. Because why? Because when there is a base flow, time taken to the water transfer from the infiltrated water to the outlet will take a lot of time, right? So within that time, your simulation time will get over. So adding that will have no sense. So in that case, if there is a long period you are modeling, long period like 2-3 years, 10 years you are simulating, in that case, base flow is important, and you can define the base flow or monthly average or different methods you have defined. You can define that way also. Okay, so coming to the presentation. HEC-HMS. Suppose we have considered the green amp model. So in that case, what I'm trying to show you is, suppose I have considered the green amp model. So loss, and I just said here, green amp loss method. Then I'll click here loss. Okay. Then I should have initial content, saturated content, what is section head of that particular soil, conductivity and imperviousness. So in this case, you must know, for this subbasin, you must know what type of soil it is. If you know the soil, then there is a table given by Chow, 1987 book. Applied Hydrology book, if you refer, there is a book. In that table he has given for different soil type, what is the section head, what is the hydraulic conductivity. From there you can directly get, suppose your soil is this kind of loamy soil, then in that case section head will be this 8.89 centimeter and conductivity will be 0.34. So likewise you can refer those values and you can directly give an input. So if you are considering, see, imperviousness means, how you consider imperviousness? Imperviousness means you must have land use land cover classified your image. If at all you have the LULC image of your area, so this is a LULC classified. How we have done this? LULC is a very big process, but I'll just say, I'll assume that you guys know how to do the LULC image classifications, and this is the ultimate image classifications. So imperviousness are those areas which have been built up, right? So where water cannot be soaked, infiltrated, it directly directs towards the it contributes to the sub-basin. So those areas are the imperviousness areas, and if you have classified the image, so I can directly say built up area is the area, percentage area where it is acting as percentage infiltration, imperviousness. So in that case, so I'll compute whatever the area, suppose is like 129. This is the area, how much, this much is the area in my basin, which is acting as imperviousness area. So total area divided by this area will be the percentage of area in my subbasin, which is somewhere as texted. In case of subbasin consists of multiple soil types, and how can we take into account, right? The question is like, suppose we have the multiple soils. In that case, see, suppose Artisan Polygon I'm adding. See, if there is the multiple soil types are there, then in that case also Artisan Polygon will come in handy, because Artisan polygons are taking for it small areas, right? Very small areas. So in that case, whichever the major soil is there, you can consider directly that. Okay. If we are considering entirely this one, this complete subbasin, for that you are saying this is the soil, a particular soil, that is not possible, right? In that case also, when you have done the Artisan polygons, this will come in handy. Where now mostly the soil will fall, mostly the soil will be uniform in this Artisan polygons. If it is not there, then you can consider whichever the major soil, like more percentage, like maybe more than 50%, whichever the soil covering in this area, you can say that soil type, and then that's one thing. And second thing is like simply suppose in this Artisan polygon, 50% soil is like 40% soil is some X soil and 60% soil is some Y soil. Then you can compute the weighted average, right? So as I given here, suppose this is sandy soil is having area 20 square kilometer and loamy soil is having 30 kilometer square. So you can compute 20 into 11.01, 30 into 8.8 divided by total area. You will get the compute on an average, weighted average, wetting front or the hydraulic conductivity. I hope that justifies your question. Okay. Okay. Once if you have done this, once if you understood this section, these parameters how to assign, then you can assign those values. You can using these using the table, you can give those values. Okay. So initial content means before the starting of my simulation, what is the initial content of my water subbasins, subbasins. For this subbasins, if there is a rainfall is occurred, suppose your simulation time is 2nd Jan, but on 1st Jan there has been some rainfall. Okay, of course this will hold certain amount of moisture into that. So that moisture you should know. Okay, and then you can define that. And saturated means how much maximum the soil this water can hold this basin. That also you have to give. And section head from the table, conductivity from the table, and impervious means when you have the LUC image classified, so you can calculate the percentage. If suppose it's within this sub basin, whatever the built up area is there, that will act as a portion of the total your sub basin. So in that percentage you have to give as an input. So once if you understood this one, so that way you can define those parameters. If at all you are considering, suppose you say you are considering loss method SCS curve number. So this is the you have to define the curve numbers, right? So curve numbers, I guess I have to put the table. Yeah. So okay, somebody asked the question. We can input only one soil type per subbasin. We can calculate weighted average soil and then match the calculated value. Just closest match will. Yeah, that way also you can move on. Okay. So once if you I just show the curve number computation. So you know the what type of soil in your area. Okay. This is the soil type. This hydrological soil group. So we can say like you can relate to your actual soil type, and then you can say in my this study area is alluvial and clay soil. So these two soils are there, C and A. These type of soils are there. So how to compute, like for a small subbasins like season polygons, small season polygons, for this how can I compute the curve number? That's a very big task, but I'll simplify for you. You can create directly in an Arcmap. You can create the directly the gridded curve numbers and directly import. You can import that into the your HECHMS. And second thing is, second and simplest way is, I know the soil type right here. I know the soil type. So this is the soil type. And if I know the soil type, and then I know the again, and if at all I know the what is the cover type, means the land use type. So soil type is B, and the agriculture, this the area is agriculture. Majorly the area is agriculture, 77. So 77. So soil number B and the agriculture is 77. So curve number is 77. Suppose there is a mixture, right? There can be a lot of mixture of different land use as well as different soil also. In that case, you can go again weighted average, like suppose built up area. Suppose there is a 3 different areas are coming in that class: built up area, agriculture area, and forest, and 2 soil class. So you can first you average out the what the cover according to the soil cover type, and then you come for the again the second and third soil group. So 2 times you have to do the weighted average, and then you can define the curve number. And one more thing, suppose how important is this curve number definition and all. Like if at all you gain an experience in HECHMS modeling, it takes hardly 2 minutes to define the curve number. How I will tell you. Ultimately, what you're gonna do? You're gonna do the calibration, right? In calibration, whatever the parameter you're going to define, it's definitely going to change, right? So if that is the case, then I can say approximately I can define if this is the classes and this is the soil group. Then I might have within this only my curve number, right? So I can say just simply for just begin the simulation, I can simply say an average curve number of this one. I can just give an input, so that will also work. And then when you calibrate, it will come to the actual match. So if you put like ultimately you have to put more effort in calibrations, of course. Okay, so thing is, I hope you understood. Suppose I'm defining the SES curve number, SA and SAS, and then loss method. When you come to loss method, then I have to define the curve number and the what is improvement, percentage improvements. Okay, curve number means suppose I got some 75 and 78, and then I got some, there is a improvements in that particular Hecke polygon is like around 0.5% of total area. So I can just say like this, and I'll say clear. So if this is done, loss method, then we'll come to the transform method. Transform method means there can be many different transform methods are there. Again, there is a 9 to 10 transform methods are there. Usually in this, we usually consider the Snyder or SCS unit hydrograph. So when you say SCS unit hydrograph, then come loss method, we have defined all the values. The values are saved here. Now transform method. So when you say the SCS unit hydrograph, in transform method, you have to define only one parameter, that is lag time. Okay, lag time, how you calculate the lag time? Lag time, I hope everyone knows lag time. How can complete it? Simply, you can, there is a Kirpich formula, or else you can use the Kirpich formula, or there is an online tools are there. So many online tools are there. So you can define using that also. So we say Kirpich formula online. So directly many people time concentration, so formula calculator. So these like this, you can directly open those, and you can, if it are for that, you have to have an area and the slope. If using these two parameters, you can directly compute. So you guys can try. I'll not put much time into that. So I hope everyone knows how to compute the time concentrations or lag time. So you have the lag time and time concentration, both you can convert 0.56, whatever the constant, you can multiply that and you can convert that. So if that is the transform method is done, then I have to have a base. So in this case, I'll just say no, because we are just defining, we are going for the event based rainfall. So in front of model, just say no. Okay. So this is the story of my one sub-basin. It means I have to define whatever the downstream is there, whatever to some junction 1, and then I have to define these three things like loss method and transform methods. Is 0.7 constant value for it may change according to catchment. Mostly it is constant. Yeah, right. Okay. So once if you define all those parameters for the one sub-basin, then you can go for sub-basin 2. Okay. So I'll just come here and I'll show you what all things I have put. So you can directly fill your sub-basins. So if you have created, just fill these values like SCS curve number, SCS hydrograph, area is 230, 250. Just try to put your values in this. Okay, for sub-basin 3, or so when you come to I hope everyone is practicing that. How to calculate sub-basin area in HECHMS. You cannot compute the area in HECHMS. You have to have an alternate options like ArcGIS. So once you do the Artisan Polygon, so you open the attribute table, directly you will be having an area. But you are connecting HECG-HMS with the HMS, there you can compute the areas. So that's an alternate option. So okay, fine. So I hope everyone please try to fill those values. If you open the HEC-HMS, just try to fill these values. I'll give you 1 minute. Okay. So HEC-HMS area is like, you can put any random area. Okay, we are just practicing. Okay, so just put any random area. Then you try to just and put this value, the SCS curve number, is unit hydrograph, loss method. There also you define the curve number and the improvement transform method, lag time. So I'll just say 120 is lag time. How you can using Kirpich formula, we computed the lag time. So we're just defining. Okay. So I just try to finish it as it is possible. Sub-basin 2, sub-basin 3. All the sub-basins you put the values. Like sub-basins, you put the area. Now you put the loss method as SCS curve number, transform method as SCS hydrograph. Then come to the loss method and click on the loss and then put the curve number. I hope you understand the curve number concept. You just randomly, right now for your practice, you just put the random curve numbers, no issues. Transform methods, lag time 20. Okay, or sorry, just put the values. Until then, I'll share you the actual model. So unable to view the parameters in the components. It's blank. How to view? Okay, so if at all you are viewing blank means you haven't. I guess you haven't clicked on this, and then you click on SubBasin, or else you must be somewhere in compute or results. Okay, be on the component editor. This should be you should be on the component editor. In the component editor, just click on the SubBasin, whichever SubBasin, all the options will appear. It's done. Explaining nicely. Please continue. Yeah. I just want everyone to please fill the values, any random values. We are practicing, no issues. Whatever values, real values, you have to imagine. All the concepts should be clear. So you will have to read some notes and all. Then you will understand what are the exact parameter that represents. How can you estimate? How can I estimate? I can help you out. How to estimate? That's what I'm doing it. But what exactly that sense of this parameter you have to read, and I hope that is covered in your previous lectures also. Notice we are just practicing. So quickly you finish the values. So I guess final, yeah. Kalpesh sir, I'm sharing you the one more file.
Yeah.
So
Yes.
have shared with them. This is whatever I'm sharing. Okay, this file is in another use. Okay. Once if you have done this thing, like values you have put for this all the subbasins, then we'll see what exactly you have to do with the reaches and the this thing. So subbasin 1 is completed. I hope everyone is completed. I'll come to the reach 1. I click on reach 1. Just see what is the values are there. Reach 1 or reach 1. Reach 1. Where is that? Reach 1. Reach 1. For the reach 1, what is the downstream? For the reach 1, downstream is what? My junction 1, right? The whatever the numbers are there, I'll just kind of define it. So for the reach 1, junction 1 is the downstream. Okay. So routing you have to define for the reach. Like what we are doing here is, we are routing this one because as I said, reaches are used to transfer the computed discharge or discharges or runoff from one place to the junction or outlet or any other points wherever you are desiring. Okay, so in that case, I should be routing, right? So I should have to route. So let's understand what are the different route techniques are there. Transform methods. Okay, as I explained earlier, SCSN standard are very famous in our like best suitable for Indian cases. Others also suitable. You just need to put some more effort to calibrate it. So these two methods are applicable for 25 to 25,000 square kilometer area. So whenever you have a sub-basin, that should be less than this. We should fall within this much area. Okay. Reach elements. So reach elements conceptually represents the segment of stream of or river. The actually calculates are performed and a routing method is contained in within the reach. Okay, reach elements means we are transferring those waters from computed from the sub-basin to any other points. So what are the different routing methods are available? The first is kinematic wave routing method. In the kinematic wave routing method, what are the different parameters are available? This length of the channel, slope of the channel, Manning's end of the channel, okay, and then like sub reaches, like you can say whatever the sub reaches be coming in between, you can mention that number. Then the slope, like if I say you can mention the any number, any kind of channel it is, and then you can say the what is the bottom width and the slope width. So these are different. If you're using kinematic wave routing, a simple parameter you have to define. But you're using lag routing method. In that case, you should compute the lag, like how much time it takes from water to reach from one point to other point. So that is a lag time, and that lag time we can define. So lag time definition for catchment is different. I'm just defining for the channels. So Muskingum routing method. So in Muskingum routing, this is like very famous method. Generally people uses it. It requires Muskingum K. K means like K usually defined in the hours. So and Muskingum X is the values varies between 0.1 to 0.5. So actually Muskingum K and X you can compute. I hope everyone knows how to compute the Muskingum parameters in your hydrology subjects. You might have computed the K and X values. So if at all you have computed that, then you can put here. If that values you are not having, then you can simply use lag method. Why this lag method? Lag method is very simple, lag method, and although it is effective also, many of the literature, even your okay. Kalpesh, I'll share that file with the students.
Yes, sir.
So I'll even your HECHMS user manual also suggests using of lag method, because this is very simple and effective method. In their manual also they have mentioned it. The lag method, this method, like simple lag method, is a very effective method. Though you can use these methods, and these are also very effective. Also, we just need to have calculated externally you have to compute these parameters and assign those values. So lag time you can compute in Kirfish only. I will not take that slide because simple and not put much into that. Okay. So once if you have done this thing, like you have for the lag, suppose you are considering reach one, just mention the reach one, click on the reach one here or click here reach one and just mention junction, whatever the downstream it is. And then routing method, I'll just say lag and then say loss and gain, I'll say no, and just say routing may. I'll just say initial type is discharge equal to inflow. That's where commonly we use, and lag time is 80. So I just saying 80 minutes is a lag time. Okay. Likewise, you mention all the lag time for your all the SubBasis, like reaches. Okay. So I'll just give you 1 minute, just finish that part. If you're finished, you can text me. I hope everyone is practicing that what I'm explaining, and then if at all you guys have done the reach element values assigned, then let me know. The lag is the same which we calculated from Kirfish equation. Yes. So I'm just giving you 1 minute. Just finish that values assignments. You just click on reaches. Loss and gain means, like, suppose see here what he's asking is loss and gain methods. If there is some constant infiltration is happening or some percolation is happening, if at all you know that, it means in that channel, if there is something addition is there, in that case you can define that also. But usually that is very small in event-based rainfall, because same day only that rainfall on the same duration only that whole discharge is carrying towards the downstream. So we generally consider no. Otherwise, if you have the data, percolation data, you can define the percolation also. Routing. So I hope please finish this thing, because after this we'll be going for the next concept. Everyone finished? Can anybody else done? Some Deepesh said has done complete. Anurag, I'm just referring as Swantikar Kumar Dubey said. Dubey sir said yes. So anybody else? Because I'm getting yes very less. I'm just giving some time to just so that you guys can complete that part. Even second, if it are like you are becoming, if you want me to repeat something, then I'll repeat again. Bhavin Rami said is quickly finish the steps whichever I have mentioned now. One is like sub-basin values, like sub-basin 1, and I just said sub-basin 1, and then these values like these parameters like loss method and transfer methods, and then the loss method, the values, and transfer method, these values for all the sub-basins. Once if that sub-basin part is complete, come to the reaches and click on the reaches, every reaches, and then say there is routing method is lag, and define the routing method, okay, for all 3 sub-basins. Can we watch this video later on YouTube? Yes, that will be available.
Yes. Yeah, yes. Because it is broadcasting on YouTube also. So you can repeat every step or any step and you can watch. Okay, I request all the participants, if you do want to watch this video, you do visit our channel Cast CSW MPKV Rauri and you can find this video.
Okay, so and data is also shared. So you can download the whole basin model. I'll be opening after 15 minutes. I'll be open that model. I'll show you what exactly how you can do the simulations. I'm just making the practice. Can we? Yeah, of course. Okay. So reaches basically represent stream conveying runoff from the subbasin to outlet. It means we should have an idea of stream shape, slope, cross section. Yes, of course you should have. That's why that when you define those things, that's why if at all you are using the lag method, in that case you do not have to have it, but only in case of masking and kunj methods or other methods, you should have an idea about what is the shape, side slopes, and everything. As I was showing in the earlier slides here, yeah, this slide lag method you don't have to define anything, but in kinematic wave routing method you should have an idea of your complete cross section of the conveyor. Okay. Okay. So once if you are done this one, then let's come to the meteorological models. This is the complete creation of basin model. Now it is done. Next is hardly 10 minutes work. We just have to see meteorological model. Meteorological model means how can you like which subbasin has which like which gauging stations and how much evapotranspiration transfer is happening, that we define using meteorological models. Meteorology means whatever the gauging stations are there, that we assign to these subbasins, and we define the what is the monthly average evapotranspiration. So you can create using this create meteorological model. Just say new meteorological model, just say new. It will ask you for the new meteorological models, and then say create. Once you create, this will create meteorological 1. Once if you create this will appear. Okay. Once if this is appeared, then once if this is appeared, then you have to define here other parameters. Just here you have to define here. The first step was basin model creation. That is a big task. Next is very simple tasks, and you can define complete within 10 to 15 minutes. It should not take much time. Like, okay, so before coming to the meteorological models, we should have to have a time series data input, because in this we are defining the subbasin also, right? So that's why we have to have subbasin. So first you go to component. First step is basin model creation. Next step is time series. Okay, so time series. When you click on time series, go to your components, create time series, and just say precipitation gauges. Here discharge gauges, all the you can define the values, but I'll say precipitation gauges, and I'll say new, and it will say gauge 3, or you can name any name, and I'll say create. Once I create, it will open this gauge. Okay, you can rename also, you can do anything. You want to edit, you can do anything with this. Likewise, if it will have more gauges, suppose I have 3 subbasins, right? I'll create 3 rain gauges. So I'll just say new again, and I'll say create. So once it is created, then I'll just close the window. So now I have created 3 gauging stations. So now if the gauging stations are already there, then I have to click on this. Click on gauge 1. Then you have to define the duration. Okay, so whatever the rainfall duration you are having interval, at what rainfall you are having the data you have to define. So if suppose you are having like 1 minute rainfall to 1 hour to 1 day, you can define until this period. So suppose if I say I have a daily rainfall day 1, so time interval, so day 1, and I'll say data sources manual entry, uses incremental in millimeters. So cumulative also you can define incremental inches or millimeters. So I'll just say I'll have rainfall in millimeters. So that's I'll say time interval is in 1 and incremental millimeters and 1 day. So once if at all you have to click on this, the gauge 1, click on this. Now you have to define the time series, time window. Time window means from where to where you have the rainfall data. So just in randomly, I'm just giving you this date like 01 to 0. My rainfall starts from 1 Jan to 2000 to 20 Feb to 2020. So I'll just say I can just directly copy from this from here. I'm just creating random data. So I'll just create. I'll select this. Once I select, I can directly come here and paste here. If I say just paste, right click and paste, so it will directly paste. So likewise, you create for the gauge 2. Gauge 2, just say here manual entry. Units are incremental millimeters. 1 hour duration. Means 1 day. Then come here. So this is the end time 19 Feb table. I'll say 0. Last one. So if you have the exact time window, so you can define the time windows and then you come here and paste the rainfall data here. And you can visualize the graph also, like this is the rainfall, how it has been occurred on your gauging stations. How much you consider for training calibration of HECHMS? Generally, model creation, we divide calibration 70 and we keep it for the validation. Somebody asked which method is better, lag time 1 or masking. Any advantage over the lag over the personally, what my experience is, method is way better because it actually has the conceptual model, but lag time is empirical model, right? So it will always have an of course 70-30% of course have a disadvantage, but still you can lag time, you can calibrate it and put it, you can well calibrate and you can give that value, so you can reach to that value, certain perfect value. So both are having advantage, like simply definitions, but in other ways, suppose you have the values of channels, you know the channel better, then better you go for the Muskingum punch methods. Or you simply want to say you do not have the information about your reaches, then you simply use the lag time. In that case also it doesn't affect much to your results. Sir, can you share user manual for the HECHMS? Surely, it's just you Google it, HECHMS user manual. Whatever you type, just Google it and you will get the HECHMS. But definitely I will share also. Okay, so let's come to the next point. We are at 41, so we need to finish this. Once if we add the precipitation gauges, okay, gauge 1 and gauge 2, then here also same time you have to define. This is we are just now added, so I'll just say 1 day and it's in millimeters and time window is, I'll say 1 Jan 22 20. I'll just say 20. Okay, then 20 Jan and I'll say table. I'll copy this same rainfall. This for your example, that's why I'm just copying this rainfall. Okay, already I have copied. Okay, so I just pasted the discharge data. Okay, I mean rainfall data. So this is how I can create the precipitation gauges. Okay, now what I will say is, what I will do is I'll add some discharge gauging stations, right? I'll say time series, I'll say discharge gauges new, and I'll say gauge 1, let it be the gauge 1, and I'll say create and say close. When you say discharge gauging stations, you should again same thing will come. I'll just say you have to mention a day period and then unit is like QMEC. Okay, so now open it. When you open it, it will ask you the date, same date. You can mention 20 Jan, 1 January 2020 table. So in this case, discharge simple. I'll just giving you the glance. That's why I'm not have the actual data also, but that's fine. This is the actual data. Okay, I'll just paste it in here. Okay, I can see this is the graph. This is the graph of my discharge gauge. I can just rename also. Should not be this. Okay, so we created all the discharge gauging stations, and we created the precipitation gauges, these 3 precipitation gauges, and this is discharge gauge. Once if it is done, then what I will say, I'll just close this. I'll close the expansion, and then I'll go to metallurgical model. So how I created, I'll just went here, create metallurgical model, new model, create model, say yes. So once if I say yes, then it will create the new metallurgical model. I hope everyone is understanding everyone is following the procedure. So can you share? Okay, if discharge gauging is not present in a basin, can HECHMS be used for runoff prediction? Yes, of course. If there is no discharge gauging station, then that is fine. It's okay. You can simply use for prediction of discharge. No issues. Okay. Okay. So once if you're done, then our next step is what? Create the component editor. So any questions? Then how to validate the? Of course, you have to. As your question says, discharge is not there. Then if you, of course, you for validation you need the discharge values, or else there is some other techniques like there are many other techniques you can develop a rating curves for ungauged catchments. So ungauged catchment concept you can use, and you can develop your rating curves, and then there you can validate. That's a totally different process and a very long process. So I'll help you out if at all you are interested in doing this for ungauged catchments. Okay. Coming to this, we'll add the metallurgical model. So I'll just go to component, create the metallurgical model. Once you create this, it will appear like this. So once you click on this, I'll say what is the precipitation. I'll say specified hydrograph. I said I have mentioned hydrograph. No, I given the hydrograph. So I'll say I just said specified hydrograph. Other ways around is like there are different ways to give the rainfall, but better is specified hydrograph. Evapotranspiration is monthly average. You can use these different parameters. Suppose different parameters. Is there any constraints of area to use HECHMS software? No, there is no any constraint. Just that which method you are employing. Suppose you are using SCS curve number or the Snyder method. There you have to see the constraints. Here no constraints. As per my knowledge, like it may be there, but as far as my knowledge, I have simulated complete lower topic basis, like around 60,000 square kilometers. So no issues. It won't have much constraints on that. Okay, so coming to the metallurgical models, you just say evapotranspiration monthly average, or else you can say these different Penman-Montet method, Priestley-Taylor method, Harmon. These different methods are there. You can either you compute externally the evapotranspirations. Okay, then you can mention here evapotranspiration. How can you calculate? Like there are many methods. Like as it said, Penman-Montet method or Priestley-Taylor. When you say Penman-Montet method, then you have to see here. Penman-Montet method. So you have to define some values for those, and then you can come like you can have the gridded Penman-Montet, or else when you say simply the monthly operation, monthly average is better. Why? Because we can compute monthly average using Penman-Montet method externally, and then we can define we can input those values. So for metallurgical models, as I said, precipitation is specified hydrograph. Evapotranspiration, none is this. Snow melt is none. For many of if your snow melt is there, if you have the data of certain catchments, then that case also you can define. But for many of the Indian catchments, the snow melt will be Sorry. So I know, because we are when we do event-based rainfall model, in that case, evaporation will be very small. That's why we ignore the evapotranspiration in that case also. Okay, so if at all you are using it, you can define that also. Which value to be given in case of monthly average method of method average for ET? When you are giving a monthly average, suppose I just said here evapotranspiration, and I'll say monthly average, I'll say yes. So when you say this each and every subbasin will appear. See, when I say none, means see everything is disappeared. Here you see there's no subbasins. When I say monthly average, means monthly average, and say yes, 3 subbasins will appear. When and as I click on this, like this rate, so you have to define the evapotranspirations. So see here, coefficient means that you must know the coefficient of the evapotranspiration, and then the evaporation you can define directly from here, monthly average. So you use the you must be known this thing to compute the evapotranspirations. FAO. So FAO has given a simple tool for calculating the evapotranspirations. You can directly compute that, or else nowadays many satellites data are also coming with the evapotranspiration rates. So that value you can define. So value here, value is like you have to either compute, or else you have to have obtain the values from the any subbasis. That's how you can define. So it is based on pan evaporation data. Of course, it is. Of course, when you are asking the coefficient, it is on the pan evaporation data. Of course, it does consider the evapotranspiration also. So okay. So once if you're defined this, I'll just say in because we are doing least important for our case. So I will keep evapotranspiration. I will keep none. Okay. Once if I keep evapotranspirations, then you have to click on subbasins, and then it'll say. Okay. So before that, basins you have to include when on the meteorological basins, basin 1 want to include subbasins, then it will ask say or no. So you have to say yes. Okay. So once you said yes, then override is no, like we say no, and basin you say yes. Once you said yes, then come to the specified hydrograph, because we have said here specified hydrograph. Click on specified hydrograph, and for subbasin 1 means this subbasin 1, which gauging station, which rain gauge you are assigning. So I am saying gauging 1 is having subbasin 1 is having gauge station 1. So I'll say gauge 1. Likewise, we are defined here different gauging stations, right? So likewise, I can define here the gauge, whichever the different gauges are there. So once if I, and then for subbasin 2, I'll say gauge 2, and subbasin 3, I'll say gauge 3. Once if you define all these 3 gauging stations, then this part is also over. So time series is also covered. This part is also over. So all three parts are over. Now I'll add control specification manager. So I'll just say new. I'll say control. Why the control specification manager is added? Control specification manager is used for simulation period. It's like how you want to simulate, how much you want to simulate. So I'll just say here my rainfall data was a day rainfall. So I'll say day. Okay. And then I'll say start date is 01 Jan 2000 to start timing is 00. So I'm just looking at the gauging one, whatever the date and time I'm given. So I'm giving the same values, right? So here also 20 Feb 2000, and I'll say 00. Okay, so this is a compute like the computation control computation manager. Okay, any questions until now? Tell me, because this is the last step we are defining. Our next step is simple simulations. If any questions you are having until now, let me know. After this, we'll be just simply going for the simulations. Can we do okay, like 20 years data? Yes, we can do computing long period. Yes, you can do for any period of data. Any questions now? Because we'll move on with the next step. I hope everyone has received the model which I given. This is a simple model which I was explaining how to give the values. Okay. Now, once if it all you all have received, then please let me know, because I'm going to open that model now. Okay. I have 18 years of data starting from 1st June 2014. Then what will be my end date time? See, if daily data means you directly put 1st June 1997. Okay, of course. See, once if at all you're having gauge 1, let's just see one here. Just observe. This is gauge 1, and my definition is 0.1 01 Jan 2020. When you see the table, it started from, you can give actual value, you can give it from 2 Jan 2000. So remember, so whichever the date you are having, just add one data and then put, because 1st Jan will be blocked here. We cannot add any data in this block. So whenever you're having the data, you just keep in mind, you have to add, you just start one day before, or else see time, because the timing is like around 12, no, like in the early in the morning. That's why still it is a one night or two morning. So this is where you have to understand which date it is. Like suppose it is like your 1st June 1997, it's in the morning they have taken, means like, of course it has to be from 31st Jan, like before that day you can just add, and that morning will be considered, and then you can define that. So you just add one day so that your period will not go miss. Okay. Has everyone received the model? Let me know. If everyone has received, then we'll start with the new model. So if this much step is clear, then this is over. Next I'll open the model which I have shared. So everyone please open the model. There we can actually, because the random data we are giving, no, so in that case we'll not be having the actual visualization of the model. That's why I'm using this one. Actually, that's why I'm creating the whole new model. Defining, showing you that whole new model. So once you open this like this, so this is the complete top basin which I use in my project. Okay, so I hope, so this is where we were creating the whole sub basin. So this was the basin, and this is the different gauging stations. So that's why I had created the different Artisan polygons. Okay, this is where the Ukai for the this basin, or the lower Tapi basin, there is a Ukai dam also, which will contributing to this one. So I had created a point of the source where it will add the discharge, and likewise I had created a sub basin. I joined junction 2 and the final junction here, junction 3. So likewise I have created this, like I showed you this part only, this part. Okay, this part might have created so much confusion and addition of data without taking much time. That's why I didn't consider that. Okay, so has everyone opened this? Because I'll just simulate this one and I'll demonstrate you what all things, because the next step is, once you are given the input, you have to simulate now. How to simulate actual model I'm showing you. Can anybody say yes if everyone has downloaded the data which I shared? Okay, so Dubesa has downloaded the data. That means the model actually. So okay, so how to open? I just said how to open. If at all you have opened that, if at all you have downloaded that, then just say open, browse. When you browse this, go to your location. I'll go to this location where I have stored. Then I'll say final. This is where I have shared you. This is what I have shared you. So this I'll go this. I'll just open this project 1. Then just select project 1 HMS. When you select this, then say select and just say okay. It will open. It will come here and then say open. So it will open. Okay. So just go here. Just direct to your PRJ file, like computer, wherever you are saved. Open here and then project 1 PRJ. The project 1, whatever the name you are name will be given, that with that name only to save the project. So this is a project HMS. Okay. Once if you have opened this, then please share file again. Okay, somebody has downloaded, somebody has an issue also. Kalpesh, just share the file again, or if somebody has downloaded and share with him. what if the land use channels properties change over the time, say 20 years? Does HECHMS has provision for this as well? No, actually, in that case, we have to have the dynamic way of doing the models. That this question is really good, because in 20 or 30% simulation you are doing it. In that case, even sometimes your whole catchment, basin catchment features also will change, right? So, okay, fine. So if the project has opened, this is a full-fledged low tapi basin. The question I'm answering here is Santosh Mali sir's question, where he has asked me the question saying, if the project has the 20-year period, then in that case, your LULC will change for sure. And so many other parameters will also change. The how to accommodate that changes in your model. So HECHMS doesn't have direct accommodation, but you can divide your modeling in different time intervals where there is no significant change of LULC or any other features. But you want to see include dynamic way also, then here that is a limitation where we cannot include. You want to include that way because ultimately we are defining the curve number, right? So curve number or any other parameters. So that will be very difficult to again make it the model is dynamic, becomes dynamic. So in that case, better you divide your 20 years data into 5 years data, and you do the calibration for 5 years, and then you start simulating whatever analysis you want to do. Okay, so once if you have done this, I hope I answered Santosh Maisa's question. Okay. Okay. So ultimately, Santosh sir, conclusion is 20 years. If there is appreciable changes, then definitely you have to divide the models in different time stages. Okay. So I'll just repeat once again this procedure. We created the Basin models. This is what the Basin models, different parameters of that. Okay. Sir, could you please tell any website to download soil type and land use cover data for surface? Okay, just a second. I'll share you the soil. Okay. I am sharing you this link. Okay, so this is the place where we can download a whole world soil map. From there, you can mask your area using Arcmap. Okay, site also I'm sharing that one also, but this better the two websites for the soil map from. Okay, once you have opened your HECHMS model, then we created your sub-basin. Later on, we added the time series data using precipitation gauges. These were the different 12 precipitation gauges I had given. And this is the different discharge station. UKI release data I had given. Discharge at 2013 means at this point, 2013 is my. Just a second. Okay. So if you have opened this model, then this once you created this one, then we added the time series. So discharge data also we added, and then precipitation data also we added. Then we created the metallurgical model. In that metallurgical model, I had given specified hydrograph. So in this specified hydrograph was month, and then your precipitation monthly average. So if you go here, expand this, then monthly average. So 60, like this is the monthly average computed your precipitation using Penman-Montet method. And there is an FAO tool also, so you can use directly that and you can compute the monthly average. And then likewise for all the gauging stations and all the sub-basins, I have computed what is the expected monthly average data, and then I have given the coefficient at 0.7 to convert the pan evaporation and evapotranspirations to the reference evapotranspirations. Okay, so this is a different components. Once if I have completed the methodology models, later on I had to add what control specifications, and this is the time durations. So 1 to 6, my time duration. So 1 August to 1 August to 8 August, like 5 August to 13. So I guess it actually it cannot over predict the models. Of course, whatever the data, if you add more data, it will only simulate restrict to the how much data we have given. Okay, so once you done the control specification also, then we'll simulate it. So how to simulate that is, okay, anybody has question, anything? Evaporation and evaporation data are same for all subbasins. Yes, of course, for this subbasins, I have just simply average the data I have given. If you have the different data, like suppose temperature data of at this nearby stations and other stations, other variable data, if you have it, then you can compare to this gauging stations or subbasins, and you can input that also. But in this case, I guess I have given this same input because that like hardly varies, no? The discharge data, the evaporation data hardly varies within like 4 to 5 minutes, so that doesn't affect much. That's why for your showing purpose, I'm showing you only that much. Or else you can also input the complete very different gauging, different monthly average rainfall. How much is the size of entire basin in kilometer square? As I tried 35,000, I guess 3,500 square kilometer, I guess, but not sure about that to see. Okay, so let's come to the simulation part. Once if you are done, then we'll directly simulate. Okay. Once if you are done, then you are done all the things like this paid time series data, control, methodological model, and this thing. Then you can have to go to compute, okay, and then simulation run. So okay, once you click on simulation run, so you just say next, next, and finish. Okay, then once if you finish it, then that simulation will come here. So I just mentioned 33rd run I did, no? So that's why it's showing here 33. Once if we select this and I have to run this one. So once if you run, so it will complete. So once if this run is completed, I have to select run 33 and I have to compute this option I have to click. Once if you click, then I have to come here, then I can visualize my complete discharge. So just remember while at reach one, at this causeway, at the causeway, I knew the discharge data, right? So I had given time series data in here as discharge 2013. So on the causeway, I just mentioned discharge 113. Though they both are gauging station or discharge gauging station appearing here. So I just mentioned discharge 113 is my observed discharge, right? That's why it is in this. When you see the graph, so it is showing you the observed discharge data also. Okay, so this is the one part of the complete simulation. I hope everyone understood how to follow. What are the different steps and idea, right? This within an hour, I cannot show you the complete. Please repeat the step. Okay. Okay. Once this we heard, right? This part, like this part I was showing you. This part is over. Like adding the subbasins, basins, subbasins, and then reaches and the junctions and the sources. If at all you added everything, then I went to the time series data. Once if I add all the time series data, I just mentioned here time series data in the time series data. Okay, so I added all the gauging station data. Suppose you click on here, so I added the gauging station data for all the gauges, like for all the subbasins. Once if I add the time series data, then I went to I created the meteorological model from all the parameters can create from here. Okay, one is the basin model. Okay, next is the time series manager from here. One is the meteorological model from here. Once if I create the meteorological model here, once I click on here, on creating meteorological one, I specified the evapotranspiration and the specified hydrograph. Once if I say specified monthly average evapotranspiration, then like this, all subbasin will appear. For each and every subbasins, I have to mention what is the monthly average evapotranspiration. Once if I know the specified hydrograph, so if I had to click on specified hydrograph, whichever the subbasins are there, in that subbasin I have to mention which for Amli, like this is an Amli subbasin. For that subbasin I have assigned gauging 1. So gauge 1 is the subbasin belongs to the gauge 1 is like rain gauge station which belongs to the Amli 1. Likewise for all the subbasin I have assigned here. Once if that is done, then I have to go for the control specifications, control components, control specifications. Once you create the control specifications, so I just say new and say create control specification. When I say it will create control specifications, and then I'll say open it. I have to mention what is the simulation periods here, like from starting date to end date. Once if it is done, then I'll say delete. Okay, once if that is added, then I'll close this one. Everything is done. Then once everything is done, then I'll say compute, create, run simulations. Please. Sir, in this project, you have simulated run or so many times. How many runs are you required? Is result different for every run? Yes, of course, I have created so many runs because every time there was error or there was some changes, right? Of course, once you have so many components added, so errors will be like you have not added the rainfall, you have not connected the rainfall, this reach is missing, something like that. So all these errors you have to eliminate, and you can run in same simulations, or actually, and these different runs are for different simulations also, different datas also. So so these are different infos. So I mean, to just to remember it, like I have mentioned so many other keywords like everything. In this also, so many other studies were also happening. That's why I have added so many data, because this is the common rainfall. So if somebody wants me to add, if somebody wants me to change only this much, suppose for one of my colleague, I wanted one of my colleague, this I'll only show you. One of my colleague wanted only the simulation for okay, this okay, one of my colleague, this Pawan wanted only simulation for this portion only, this first portion. Okay, so in that case, in that for this simulation, before creating the simulation, I can go to meteorological models. So I'll just say here the photographs. I'll just say here none. Means suppose I don't want to include some subbasins, then I'll say none, and then in that case it will not consider, right? So if that is not considering, then that will not convey components. So one of my friend wanted only this much part. This part is comes under the upper canal. Like there are two types of canal. There are two canals for this river. One is the left side canal and right hand side canal. So left Kakrapar canal and right Kakrapar canal. There are two canals. So he was simulating only for upper canal, upper like left upper portion. So for him, I simulate that one, so I can disconnect all the components, and I can simulate only those components is required. Likewise, I can do. Okay, this is how the flexibility is. Okay, I will end this session now at this point. In the second session, before starting the HECHMS, we will start the we'll do the optimization of these parameters. Okay, how to decide the base flow. So we'll discuss all these points in the second session. It's already 12 now. So this part will continue for, because HECHMS will not take much time. It's like within an hour we can finish all HECHMS simulations. So we will discuss this for half an hour, and then we'll go for, sir, there is any area limit for this model? No area limits. Okay, so I'll end the session now here. We'll in the next half, like for half an hour, next session I'll show you how to optimize those parameters. Like I have given you, we have mentioned the parameters, right? Suppose if I open this here, basins, and then here there is a reach one. So these losses parameter I have given, I have not optimized it. So that's why, that is the reason why. That is the reason why here those values are not exactly matching right now. See, these are the values. The peak is missing. Peak is not matching. This peak is also not matching. Somewhere there's so much error is there. So how to optimize that values is the next half an hour work. So we'll do that work and then we'll continue the HECRAS. Fine. Kalpesh sir.
Yeah. Fine, sir. No problem. We will continue this session to next half an hour or 1 hour.
I wish you guys have liked the presentation and the complete
Yes,
simulations.
yes.
Whole model I have given for your practice. So you can modify, like you just store the copy of it. You can modify whichever way you want and you can try, right? How you learn that, just you try and error. Like first creating the first model is very difficult. Once if you have created the first model, you can do as much trials as possible and then you can have, can understand if this changes, then how this model will work, what error will come like that. And if all that error will not come, then in that case you can have directly. Sir, can we get the PPT description for various loss methods? Yes, of course. I'll share you the complete report also if you want. Of course, the organizer is publishing a complete book on this presentation, right? I mean, the entire session. So in that, I will include everything, all the material, whichever I have used, the loss methods and everything, I'll include and I'll share. In meanwhile, I'll share other materials if you want. Yes, sir, please share the link of extension, sir. Thank you. Okay, so in the next session, we'll do the uncertain analysis, or we can say calibration validation, and then we'll come to continue with the HECMS. Fine.
Yeah.
Okay, so Kalpesh sir, are you there?
Yes, I'm here. Yeah. Thank you so much, Praveen sir, for your presentation
for your contact
session on HECHMS. Yeah, will we go continue this session in afternoon for another half an hour or 1 hour, sir? 1 hour or half an hour is in sufficient.
So I have shared my email ID. You can contact me anytime.
Yeah. Sir, we will continue this session for another half an hour or 1 hour in afternoon. Hello.
So I will just end the session. If nobody are here, I guess I'll just call them.
Yes, I'm here actually. You're not able to hear me? Hello? 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 Am I audible? Hello? Yes, actually the participants
Kalpesh sir, are you talking? You are still not here.
Actually, the participants are able to hear me.
You're not able to hear you.
Okay. Thank you, Mr. Praveen Rathod, who is a senior research scholar at Surat, for giving very nice presentation and demonstration of HECHMS model and how to model the rainfall runoff simulation in HECHMS. Yes. This session will be continue another half an hour or 1 hour in the afternoon session. So please be with us. Yes. Please be there with us in afternoon session, and we will have continue to this HECHMS and next for hydraulic modeling using HECRAS. So I am very much thankful to all the participants who patiently listens the today's speaker, and also I am very much thankful to our speakers, Mr. Praveen Rathod. We will be there at 3 p.m. exactly. Thank you one and all for joining.